Currently, I work on a project which has kind of been my idea with the help of a few other guys in the lab, and it involves the technology of natural language processing. And you and I can stand here and understand each other, but a computer can't really understand spoken dialogue. So the project revolves around how a computer can take input, unstructured text, English, and how it can actually draw meaning from it. And that's a hard task for a computer to do. It takes a lot of processing power, it takes a lot of grammar sitting within the computer so that it can make judgments on what's being said. And that's all very well, but then what relevance is that in the real world? Well, the area that we're looking at is in the aerospace domain, where typically you might have, for a wing of a plane, you might have 12,000 pages of unstructured text just to describe the design of the wing, along with all the stuff that's held on a computer and CAD systems. Typically, a few people are in charge of updating that, on making sure that if a requirement changes somewhere at the start, that 100 pages further on, that if that requirement is used again, say like the stretchiness of the material of the wing, if that's changed, then that all the other places where that requirement's mentioned, it has to be updated. And how we're trying to do that is being able to understand the natural language and find within the 12,000 pages of specification all the places where a particular requirement is mentioned so that we can trace through it, and if anything changes we can keep everything very accurate, and the designers then don't have any problems of making the wrong component, and then the manufacturer has the cost of that because it's wrong. That's one of the things that I would be involved in, and that requires a lot of hardware research. So processing natural language is very hardware intensive, so you couldn't just do it on your desktop PC. And it also takes a lot of advanced software, so the algorithms that are used to understand grammars and syntax are also quite advanced. And then being able to present all this information to the user. No way does somebody want to have to sit and look through 12,000 pages of text. So how do we present something of that size to a user so that they can navigate it quickly? So that pulls in areas of user experience, human-computer interaction. So we're looking at how people can interact with the screen that they're looking at, and how they can navigate through a large document and navigate where all the changes might need to be, etc. So we need to study users as much as we study the hardware as well to get an effective solution to this problem.